Yeah, so hello guys, this is Scribe AI. I'm going to show you what it does in a second. So the first thing you do is you take pictures of whatever problem you want to solve. So I have a list of problems here. You can see from linear equation, quadratic equation, matrix, circle theorem, and proofs. That's Euclid's proof. That's a proof that all there's an infinite number of prime numbers. So I'm going to start off with the linear equation first, and you're going to see what it does in a second. Sorry. So we just go ahead and crop it, and yeah, send the request. So yeah, I designed Scribe to give you that
3x plus 5 equals 20.
That's going
Subtract
to
5 from both sides.
at the same time.
3x plus 5 to 5 equals 20 to 5.
And
3x
this
equals
is
15.
Offline. This is like on
Divide
device,
both
so you
sides
can
by
literally
3.
get tutorials like this.
3x
on any
divided
of your
by 3
assignments.
equals 15 divided by 3. X equals 5. Therefore, the solution is x equals 5.
You understand? So that's one very simple basic problem. Let's go to something more interesting, like quadratic equation. Oh god no.
Solve the quadratic equation.
And you also get the audio feedback too.
X squared 5x plus 6 equals 0. 1. Factor the quadratic expression.
Now it's going to obviously use a factoring
X2,
method because
X3
that's the
equals
easiest way to
0.
get it. But then we could ask it to use a specific type of method.
2. Set each factor equal to 0 and solve for
that's
x.
why I have the text input. I'm going to ask it to use the
x2 equals 0 or x3 equals 0.
Quadratic formula.
X equals 2 or x equals 3. X equals... Therefore, the solutions to the quadratic equation are x equals 2 and x equals 3. Solve the quadratic equation. X squared 5x plus 6 equals 0. We can solve this using the quadratic formula.
And you also have the landscape view, so in case you want to watch like this, you're free.
X equals frac BPM the square root of b squared 4ac 2a. In our equation, a equals 1, b equals minus 5, and c equals 6. X equals frac minus 5 pm the square root of minus 5 squared 4 1 6 2 1. X equals frac 5 pm the square root of 25 to 24 2.
It's going to get you all
X
your
equals
answers.
frac 5 pm the square root of 1 2. X equals 5 pm 1 divided by 2. Therefore, we have two solutions.
I would have done a polynomial equation.
X equals 5 plus 1 divided by 2 equals 3. X equals 5 to 1 divided by 2 equals 2. The solutions to the quadratic equation are x equals 2 and x equals 3.
Is x equals 2 and x equals 3. So that's your solution you get. And also, if you don't understand it this way, you could ask it to go again. It's all going to as much as you want. Like this is on device, this is offline. This is like something you should use ChatGPT for, right? So again, we have like matrices. Matrices are one of my favorite things because I train machine learning models and get to mess with tensors too. Hiding values and hiding vectors. I would have
Given
that
matrices A and B.
Let's just do this one.
The equals begin B matrix 1 and 2 3 and 4 and B matrix.
This
B
will be
equals
overlapping,
begin
but
B
this you can see
matrix
it.
5
Come on,
and
guys.
6 7 and 8 and B matrix. Find the matrix product ACDOTB.
The dot
Matrix
product.
multiplication is performed as follows.
So it's going to show you how to do dot product multiplication between A and B.
ACDOTB equals begin B matrix 1 times 5 plus 2 times 7 and 1 times 6 plus 2 times 8 3 times
This one
5
is not
plus
very
4
clear, so you
times
can
7
also
and
say
3
if it's
times
not
6
clear
plus
or you
4
don't really
times 8 and
understand
B matrix.
the method it's using, you can literally send the request again, and it's going to bring a whole new. You have to bear with me because this is it's on device. But then I brought a solution to this.
Given matrices. The equals begin B matrix 1 and 2 3 and 4
So,
and B matrix.
the normal way it does this is that it's supposed to process all of this on a device, like using the liquid AI model that's currently there, right? The liquid AI vision model. But what I've done is that I created a network where it's sort of like a decentralized, I would say like a decentralized network and a blockchain simulation. What it's supposed to do is that it's supposed to, for example, if all the multiple devices are connected and they are all connected to the internet, because these devices, they have good CPUs, they have chips that support AI, that allow you to run models, and they are pretty good, you understand. So I decided to create a network where we have a bunch of all these devices, and then when somebody brings in a very complex mathematical problem that requires a lot of computational power, it's going to break down this problem into tiny bits and distribute to all the devices that are currently on that decentralized network. Decentralized in the sense that there is no head device, you understand, like all of them are all equal nodes on the network, and they are all going to solve them and then return them back to the device. So in case you have very complex mathematical problem that your device might not be able to take care of. And I think it's one of the very good parts of having on-device machine learning models, is that you are able to you don't have to rely on any third party or any data center or anything. You're able to run and completely process your data on device. So yeah. And also the blockchain, the whole thing about the blockchain, I call it a blockchain simulation. It's not an actual blockchain, because what happens on the blockchain simulation is that all you do is that you just it stores a record of all the math stuff that has gone on. I don't know how to simplify it, but it basically stores a record of all the math stuff that has gone on, and it uses that to improve the output every time. So when you ask a question, if there's a lot of histories on like past questions that you've asked before, it's going to use the data from that to improve the response that it makes at the time. So yeah, it's really cool. So let me just go to the next one, and that is Odon quadratic equation, linear equation, scalar theorem. This is also my favorite because it involves diagrams, and I think that's one of the most tricky things. If you ask ChatGPT to help you with problems like this, it will probably just give you a line by line text view of everything, and maybe like pass it into using some hypertext or something like that. You can see
90 degrees.
that's a problem.
In the given circle, AB is the diameter and C is a point on the circle. Triangle ABC is formed. OA equals OB equals OC equals radius R. Consider hollow up pointing triangle OAC. OA equals OC radii, thus hollow up pointing triangle OAC is an isosceles triangle. Angle OAC equals angle OCA equals x. Similarly, in hollow up pointing triangle OBC, OB equals OC radii, thus hollow up pointing triangle OBC is an isosceles triangle. Angle OBC equals angle OCB equals y. In hollow up pointing triangle ABC, sum of angles equals 180 degrees.
And also I don't making this type of
angle BAC plus angle ABC plus angle BCA equals 180 degrees.
The second year
x plus y plus x plus y equals 180 degrees. 2x plus y equals 180 degrees. X plus y equals 90 degrees. Therefore, angle ACB equals 90 degrees.
So this was, I think, to prove that angle ABC is equals ACB is equals 90 degrees, and that's what he has been doing this whole time, and that's correct. So finally, we're going to the proof. This is Euclid's proof, and I'm guessing it's going to do the proof. It's going to prove it by contradiction. That's is the most popular way of doing this. I think it's the only way of doing this. You guys are MIT students, so you can you might as well just.
Proof that there is an infinite number of prime numbers.
So that's pretty much it, you know. We're able to do more stuff here.
Assume,
like graphs,
for the sake
like
of contradiction,
graphs,
that there is a finite number of prime
maybe,
numbers.
Maybe later on we work on like 3D stuff, because this was built under 2 days. Imagine if I have a month or two to build this and capital. It's going to be insane stuff.
Let's list them as P1, P2, P3, Pn, where Pn is the largest prime.
These are the steps. So for this one, we can go like landscape, so you see it clearly.
3. Consider the number n equals P1 asterisk P2 asterisk P3 asterisk Pn plus 1. 4. N is either prime or composite. 5. If n is prime, then our assumption that Pn is the largest prime is false, as n greater than Pn.
Cool. It's kind of like basic, but you know the fact that it came out earlier. Assume there are. So we're going to be using the contradiction method here, and then what it's pretty much doing is that it said if there's a finite number of prime numbers, right? So if there's a finite number of prime numbers, we have a list of prime numbers, right?
Then it must be divisible by at least one prime number, say pi.
So that is the largest prime number, and then you now consider a set of prime numbers starting from P1 up to Pn, the largest prime number plus 1. So you know when you add 1 to a prime number, it's either that number when you add 1 to a prime number or when you add 1 to the sum of all the prime
7.
numbers.
Since pi is one of
prime
P1,
number or
P2,
not a prime number.
Pn,
So
it
now
must
if
divide
n
P1
is a
asterisk
prime number,
P2 asterisk
what this one
Pn.
is pretty much saying is that if m is a prime number, right? If m is a prime number, then we'll assume that the largest if m is a prime number, we assume that n, because n is this number plus 1, then we assume that
but pi
n is
cannot
obviously
divide
bigger
n
than
equals
Pn. So
P1
meaning that
asterisk
Pn is the
P2
largest
asterisk
prime number, meaning that
Pn
there
plus
is
1,
an
because
infinity
if it
number of
did,
prime
it would
numbers.
also
But
have to
n is
divide 1,
not-
which is impossible.
Yeah, you understand. So if okay, I'm just talking about this stuff here. You guys are seeing everything. Yeah, it will help you to understand it. Download the app and then you get a better understanding. It's explain it for you. I'm just here happy. So that's pretty much it. I just built this beautiful Scribe AI app, and then also the thing I would show you on my laptop, and my laptop screen is not good, and my keyboard is kind of like my keyboard. Most of the keys on my
9.
keyboard
This
don't work.
contradiction proves that our initial assumption is false. Therefore, there must be an
Most of
infinite
my
number of
keys
prime
on my
numbers.
keyboard don't work. I borrowed a keyboard from one of our neighbors that is like down the road. So that's pretty much what I'm using. Yeah, and the screen is not very clear, so I can't really film it to show you guys. But I've showed you guys some of the functions that I used to create the network and stuff like that. If there's any way I can screen record it and send it to you, I'll screen record it and send it to you. But yeah, that's pretty much it. Scribe AI, guys. Liquid AI.